Part 6 of multi-threading series, let us try to fix the starvation issue that we observed in last video. Okay, in last video we used the synchronized block to make sure these methods read and write are thread safe, and at any point in time if one of the thread acquires this either read or write method, other thread has to wait until the resources becomes free. Okay, and there was some unfairness all the time. Writer was dominating over the reader because this T1 is actually having high priority compared with this T2 which is having low priority. So writers are basically dominating over the readers, and it is getting more time. This writer is basically getting more time from the CPU compared with the readers. To avoid this issue, what we can do is we will use this reentrant lock. Okay, let me create the instance of reentrant lock first. Now that I have created the instance of reentrantLock, instead of this synchronized block, what we can do is we will use this lock.lock method. Okay, and once the critical section is done, we'll put this lock.unlock method. So once a thread appears here, it puts a lock right over here. The other thread has to wait until this lock.unlock method gets invoked. Okay, so I'll do same operation in this read method as well. Now that I have put this lock and unlock method, when we try to run the code, the behavior is kind of still the same. Still the writers basically dominates over the readers because it has high priorities. Okay, so still there is unfairness because by default this reentrant lock provides unfairness. So a thread which is having high priorities, CPU basically allocates time to that particular thread. Okay, to avoid that scenario, what we can do is we will provide here a simple flag that is true. Now that we provide this flag as a true, so it will be fair. So at any point in time, if thread are waiting basically in a queue, so whatever the thread that is available or appeared in a queue first, it will get chance. So once we try to run the code now, we notice that in output, so reader first basically got a chance, then writer got chance, then reader got a chance, again writer. So we notice that alternatively the thread which appears first, okay, it is not necessary to alternatively also it basically appears, but thread which appears first, it will get chance, and there is no priority at all. So even if thread 1 is having high priority, still the reader is basically performing the task because it is getting resources from the CPU, then writer is basically performing his task. So there is some fairness, that is something what we can notice right over here. So yes, with this we are actually trying to fix the starvation issue, but of course there are disadvantages as well. There will be performance impact of using this particular fairness tag. Okay, as in there will be a lot of context switches between these two different threads, and of course CPU has to perform a lot of operations. This context switching basically impact on our performance. So of course we have to carefully think that whether we have to use this fairness or unfairness, so that is completely upon the design of the code.